Hello class, welcome to class. Today it's Wednesday, October 23rd. We're going to do three things in class today. I'm going to try to return this finance redo. Hopefully I had it marked by now. I have to fight with this giant cat in order to mark the test because he likes to lie on it. He's a very interesting feline friend. Anyway, then I'll do a quick notation thing on factorial notation in 4.2. It'll be a mini lesson today because I want to give you a little bit of time so that you can prep for tomorrow. And now a message from Mr. Friesen.
Hi guys, good luck on your math class today, and watch out for cats. They like to eat tests and students.
Okay, so here's our document again. We're going to flip to 4.2 and 4.3, and we're only going to do part of this, so we're just going to do the 4.2 kind of stuff on factorial notation and permutations, okay? So you got it? I hope you've opened the document. All right, so we're going to look first at this example. Mr. Morrow owns 8 cassette tapes from the 80s. In how many different orders can they be played? In other words, I'm going to play my super terrific first cassette, then my second cassette, then my third cassette, then my fourth, etc., etc. Okay? How many different orders can I play that in? Well, let's think about it. I have to first choose the first cassette. I have 8 different choices for my first cassette. Then I have a second selection to make. I have to choose the next cassette. I actually only have 7 choices for that second one because I've already played the first one. For the third cassette, I have 6 choices for that one. For the next cassette, I have 5 choices. In the next cassette, I have 4 choices. In the next cassette, I have 3 choices. And the next cassette, I have 2 choices. And the last one, well, I just have to play the last one. That's Thriller by Michael Jackson. Anyway, you multiply all these together using the fundamental counting principle, and that will tell you how many different ways I can arrange my 8 cassette tapes. Now there's a nicer way of writing this. In fact, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 can be summarized as 8 exclamation point. That's called 8 factorial. 8 factorial. Okay? In general, we have a rule for writing that, n factorial. Well, how do we write n factorial? N factorial means take the number n and multiply it by the number below n, which is n minus 1, and multiply it by the number below that, n minus 2, and multiply it by the number below that, and the number below that, etc., 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 all the way down until you get to 2 and to 1. So that's our general statement for that. Okay? Zooming out on the side here, we've got an extra little definition to give you. It's strange, it's a bizarre definition, but we define 0 factorial as the number 1. Don't ask why. Okay, moving on. We are going to simplify the following things. Okay, you could ask why. I just won't answer. We're going to simplify the following. Okay, 10 factorial divided by 9 factorial. Ooh, this is exciting. Well, I can write it this way. 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 9 factorial, which is 9 times 8 times 7 times 6 times 5, my hand is cramping up, times 4 times 3 times 2 times 1. And notice, hey, wait a minute, I've got a 9 and a 9, an 8 and an 8, 7 and a 7, 6 divided by 6, 5 over 5, 4 over 4. Oh my goodness, this just goes on. And look at that, what I'm left with is the number 10. There might have been an easier way to write that. In fact, there is. We could say 10 factorial is really just 10 times, well, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is itself 9 factorial. So 10 factorial is the same as 10 times 9 factorial. And that's, of course, over 9 factorial. Hey, look, the 9 factorials cancel out and we're left with a 10. That's a much nicer way of writing it. Okay, let's take a look at the next example. I'd like you to cancel out factors in examples B and C, and then we'll take it up in a moment. So please pause the video now. Okay, welcome back. Here we go. So the first one, 5 factorial, we'll just leave that as 5 factorial in this case. 7 factorial is 7 times 6 times 5, etc., etc., times 5 factorial. Cancel out the 5 factorials. That's going to give you a 1 up above, and it gives me a final answer of 1 divided by 7 times 6, which is 42. The next one on the end here, I'm going to pause the video and write out the first step. And continuing on with this video, look at that. I've gone and written out the first step. 12 factorial, 12, 11, 10, 9, 8, etc. 8 factorial over 8 factorial, those can cancel. Okay, now we got still a lot to do, but it's actually not that bad. You notice that 4 times 3 is the same as 12? Cross those out. Hey, look, I've got a 10 over 2. 10 divided by 2, that's 5. And now I'm left with, to find a final answer, 11 times 5 times 9. That is 99 times 5. That is 495. I hope I got that right. You can correct me on the next class. Okay, and then the last one we'll do is n factorial divided by n minus 2 factorial. Well, that seems really complicated, but it just isn't. This is n times the number below n, which is n minus 1, times the number below that, which is n minus 2, and on and on and on. N minus 2 factorial will leave the same. And notice now I can cancel out the n minus 2 factorial, and it leaves me with a final answer of n times n minus 1. Okay? I'll leave that last exercise for you to take a look at. I'd like you to take a moment to define the term permutation. Permutation can be found in your textbook. Okay, so please look that up right now. Okay, welcome back from looking that up. Let's see, a permutation? Well, that's just a way of writing distinct objects in a distinct order. For example, the 8 cassette tapes above. The 8 cassette tapes can be arranged in a bunch of different ways. So they are distinct objects that can be arranged in a distinct order. Just to give you an example of that at the bottom of the page, there are 6 people standing in line for a movie. How many ways can those 6 people be arranged? Well, if we think about it, I have 6 choices for the first person, and 5 choices for the next person, and 4 choices for the next, and 3 for the next, and 2 for the next, and 1 for the next. Or I could have written right from the start, there are 6 factorial ways of arranging 6 people in a line. That's what we call a permutation. There are 6 factorial different permutations for these 6 people. All right? I'm going to pause the video again and write down some homework for you to do, and then I'll tell you 1 or 2 things about it. Okay, so there's your homework, page 243, and you can read all the numbers off. And now for the rest of the class here, you're going to want to balance your time between 2 things. First off, you got to get ready for that set test that we're doing on Thursday. So it's set and conditional statements. You're going to want to have a reference sheet ready to go for the test, as well as take a look at the chapter review questions that we talked about. But in addition, if you've got extra time right now, why don't you start taking a look at this factorial notation stuff, which you can either do right away or do this over the weekend after the test is done. Okay, bye for now.